Hello, this is Ramin, and this is a short video about sourceCREATOR compiler to introduce you to what sourceCREATOR compiler is and how it works. So this is a source-to-source compiler, if you like a technical phrase, or a less technical phrase might be a text processor, because essentially it's not specific to any languages, and sourceCREATOR compiler can take a number of templates with placeholders, merge them, and then generate the text at the end, or some sort of source code which you can then pass to any conventional compiler to compile. So as an introduction about myself, again, my name is Ramin. I'm a software engineer or programmer, if you like, although sometimes the work I do just needs knowledge of programming rather than doing the actual programming, which is why I like to call myself software engineer. But I've done a lot of programming work on game projects in game companies, on, for example, low-level assembly programming stuff, or even the open source Android project, and lots of low-level as well as high-level programming work in C++, assembly, C#, and other languages. sourceCREATOR compiler came out of basically a need for better abstraction, better encapsulation, if you're familiar with object-oriented programming concepts. And I basically created this compiler to help me in my day-to-day work. So let me explain what we are going to cover in this video. We are going to write a simple program to output hello world. So a simple program in C++, if you're not familiar with C++, would normally look like something like this. You have a bunch of header files that you need to include. You have a simple function called main. Like this, which is supposed to return the value 0 if it does succeed in doing what it wants to do. And you can output stuff like hello world. But instead of writing the program like this in a very simple, straightforward way, we are going to use sourceCREATOR compiler and write the program using three components. These three components: Cpp function, Cpp main function, and Cpp program. Let's have a look at them. A C++ program, as I just explained to you, includes a bunch of header files. You can see that this component defines a header file, IOStream, and then has a placeholder for any other header files. And then the main content of your program will land here on line 8, the CPP content. We'll get into that and how it works. And later on, you will see that we are defining a Cpp main function by using Cpp function. So we have a component called Cpp function. And how is a C++ function defined? Well, it has a type, a function has a name, a function has a bunch of parameters, and a body. And in this case, our function is returning the variable ret. And we have a main function, a component called main function, which is a special version of the C++ function component. It's called main. Its return type, or its type in C++ is int or integer, and the parameters are argc and argv. The body of this function sets ret to 0, and it outputs hello world, as you saw in the original program. So let's go ahead and see how we can use sourceCREATOR compiler to define our program in a more structured way, as you just saw. What you might have, which is what I have here, is a package, a tarball or a zip file, compressed file, which contains the source creator. So let's go ahead, unpack, and then have a look at the content. Apologies for the extra noises that my MacBook Pro makes. Now, it's worth mentioning that sourceCREATOR can run on Linux, Mac, as well as Windows. I'm using a MacBook Pro, an old MacBook Pro actually, to record this video, which doesn't make much of a difference in terms of functionality. If you're a Windows user and you've never used Unix, Linux, or a Mac or similar systems, then the way I work here using these commands might look a little bit unfamiliar, but I try to do my best to explain what those are. So, this is the content of a typical sourceCREATOR compiler package. What you can do is run a script called bootstrap to make sure that everything works fine. And if everything does work fine, you will get a message at the end with a smiley icon, as you can see here. So, to test that your application does actually work, your compiler does actually work, you can run test. It produces some content, and now you can be sure that you've got all you need to start using the compiler. So, let's start with a very famous simple program, a C++ program called Hello World. I create a file called cppprogram.cpp, and in that file I go ahead and define a simple program. Now, if you're not familiar with C, C++, or similar programming languages, don't worry, it's just a simple program. Which, as you can see, consists of only a few short lines of code. Here, what I've done is I've defined a C++ function called main, which is the first function that runs when you run a C++ program. And in it, what I'm doing is returning value 0, which means everything went well. If you've never used C or C++, if you've never programmed in this language, then this is actually a good chance to learn a little bit about how it works. And next, what I do is I tell my compiler to generate code required to print out this simple message, hello world. And that's it. This is a small C++ program that we can use my GNU GCC compiler on this MacBook Pro to compile and run. As you can see, I've just run the compiled version of the program and it printed out hello world. So let's quickly move on to using sourceCREATOR. We have a program. It's a very simple program, and from sourceCREATOR compiler's point of view, this is just a bunch of text, and it can be turned into what is known as a sourceCREATOR compiler component, or a sourceCREATOR component. And the way we do that is we run the sourceCREATOR compiler scc. We send this file that I've just created, this source code that I've just created, to the compiler, and it produces a simple component called Cpp program for me. You want to check, you can have a look under the components directory, and as you can see, these files exist, which shows we have a component corresponding to that source code. So how do we use this? Well, we can use the same test program as we used before. You don't need to specify the path, you just need to specify the component's name. And what this should do is generate output based on that component that we just created. There we go, that's the output, which is basically simply the content we put inside the component. What we could do is we can output that content to any file, for example or let's call it b.cpp, and now b.cpp contains the output of our component, which is, well, simply the code that we just wrote. So what we can do is now pass this b.cpp to the compiler. It's basically the same program, and say please produce b.out from our file b.cpp. And b.out is now a program that can print hello world, just like the original program. But this time we know that b.cpp, our source code that we sent to our conventional GNU compiler, was produced from a sourceCREATOR component called cpp program. This might not sound very exciting, but this is how the concept of components in sourceCREATOR works, and this is how we can use the compiler. Now let's go ahead and make this a little bit more interesting. What I would like to do is to define my program in a slightly different way, using two other types of components, or two other components that I would like to call cpp function. By the way, the extensions don't matter. I like to put the extension sourceCREATOR component, or SCC, at the end. But if I put the .cpp at the end, a lot of tools like vim or vim that I'm using here will be able to do syntax highlighting, or basically showing the code in a pretty format to me. Once I've defined a component called cpp function, I would also like to define another component called cpp main function, which is a more specialized version of the generic cpp function. Now let's go ahead and see how we can do this. A cpp program, a C++ program, is just like so. It consists of a bunch of headers, such as IOStream or possibly other header files. What I've just done here is I defined a placeholder where the C++ program should keep the include statements, like the one on line 3. Next, what I will do is I will replace all of that with another placeholder called the cpp program content, or I could just simply call it the cpp content. And this placeholder will be responsible for placing anything sent to our component with a container called the cpp content. Now I would like to define these two placeholders as global placeholders, which means any component from anywhere in our sourceCREATOR program could output to these two locations. So you can see that a C++ program is now looking like a generic template, a generic way of defining your C++ programs. Next, what we would like to do is define what a C++ function looks like. A C++ function normally has a type. Notice I'm just giving these placeholders random names on the fly. There is no requirement whatsoever from source creator to give these any particular titles or names. So you can see we have a return type, we have a function name, and here we are going to define another placeholder called function parameters. Now it's very important to point out that these are not really sinks. They don't want to sink in lots and lots of content. They probably just want to be simple attributes of a C++ function. So we differentiate them using the @ sign. The next thing to notice is that a function needs to define some sort of variable to return. So I define a variable called return, and the type is unknown at the moment, but whoever who defines such function will define the type for us. And we say that ret is expected to be filled in the body. Now, where is the body, or what the body is? Again, we don't know. We would like to make that another placeholder as well. So I call it function body here. And now we have a template for a C++ function. Now, notice this could be any programming language. It doesn't need to be C++. It can be Java, JavaScript, Perl, or whatever language you are using. Python, maybe, for example, in your project. The other thing to mention, just before we move on to the next component, is that we would like this function to be placed in a C++ program where we have the CPP content. So we have to contain this function in a container, or a so-called output tag, or output block. And that will ensure that our function is sent to the right place in the C++ program. So we have a placeholder in the C++ program called the CPP content, and the CPP content, if we ever instantiate or create a CPP function, then the function will be placed in the right place. So now we have defined a function, a generic function. Let's go ahead and use it before we move on to the next part, which was defining a specific function called main. We should be able to, if I have not made any mistakes, we should be able to just simply use these two components, CPP program and CPP function, to produce a program. So I go ahead, recreate a new component from my CPP program. I go ahead and recreate, or well, for the first time, create a CPP function component as well. We've got those two. Now we need to use them. How do we use them? Well, we create another component, another kind of a main project. I could call it project.scc, source creator compiler, and in the project I will tell the system that I would like to have an instance of a component called CPP program. And my CPP program, in my CPP program, I would like to use a function, a CPP function, with the function name equal to something with a function type equal to int or integer, and with the function parameters equal to none. I basically don't have any parameters in this function. My project would like to also contain comments such as how to build, for example. Well, this is how we build it. We say g++, source.cpp, and we can say then how to run this. These are just some comments I would like to include. How to run, make it look pretty, a.out, because g++ outputs a.out by default. Or we could actually go ahead and give it some sort of name, a better name, source.out, and ask the users to run the program like that. Just one comment here. The fact that we have instantiated Cpp program and one Cpp function does not mean that the content of these two are going to be printed out. What we need to do is to tell the program that we want the content of Cpp program to be output when we run this program, when we run this project. You will see later why this is required. So let's go ahead and actually compile this project.scc as well. And if everything was correct, we should be able to see project outputting the content that we expect, exactly as we expect. So you can see what the project is doing is showing us firstly how to build, how to run. This is what we typed inside the project. Next, it's showing us what the program was. And the program, let's have a look again. The program is some comment at the top, include other headers if there are any, namespace, and any content. And the content, we specify that we have a C++ function, and the function is defined like so. So let's come back, have a look. We have the comments from project. We have this is a C++ program. The headers, there was no other header file, so you can see that there is nothing added. And namespace followed by whatever output was sent to the CPP content. So this program can be compiled. If I show you, I can output this project to something called like source.cpp, and I can actually run it like we wrote before, source.out, and we have a problem. Well, there is no main function. How can we define a main function? We do have a function because we defined it in our project, int something, but well, GNU compiler requires a function called main. So let's see how we can do that. Well, we have what is known as a C++ function. We have a component known as a C++ function. Now, let's see how we can actually use it. Well, a Cpp main function we know is basically a specialized function, so why not instantiate an instance of the Cpp function first. A plus indicates that we are instantiating Cpp function, and we go ahead and say function name is main. This is how we specialize. We say that type is integer, and we say that the parameters are argc and argv, like so. The next step, so the function is taken care of. We don't need any of that. We don't need the return or any of that. We just need to define the body of the function. And if you remember, let's go back and have a look. The body of the function should be contained in what's known as func body, because the content of that container will end up in this place in a function. Apologies for the sound again. And that is the end of our body, function body container. Let's not forget that in the definition of our CPP function component, we expect that the variable ret or return should be filled in the body of the function. So we do that as well. And we save the file. Now, it's important to point out that you don't want this function, but this container called function body or func body to be spilled out of the CPP main function component. It is possible for other components to ask about the content of CPP main function, and if they see function body, they might assume that they can just go ahead and use this. So we don't want other components to be able to access this. Therefore, we just say this is a local component. And that's about it. We can go ahead, use the sourceCREATOR compiler to compile our newly defined CPP main function. And let's see how we can use that in our project. I would like to use this new function in our project. This is how we do this. I've added a line, CPP main function. And so I should compile my project again with the sourceCREATOR compiler. Now we have a component called project, which refers to other components such as CPP main. Let's have a look. Such as CPP program, CPP function with the name something, and a CPP main function. Let's test the project and see what comes out. Don't make the mistake of putting .scc at the end, because you're referring to the project component, not the source of your project. And bingo, we have what we expected. We have a main function being produced as a result of instantiating the CPP main function in our project. Let's output this content to source and again get the GNU compiler to produce it, to produce the final program for us and call it source.out. Now I expect this time, yes, this time it went ahead and compiled with no error messages as we had before. If I run what I just created, I should see hello world. Now, of course, you might be wondering, why go all the way, all the length to creating such a complex program, such a complex set of components called CPP function, CPP main function, CPP program. And what's the point? We could have just had the simple program at the beginning, and in the next section I'm going to show you what the reason is.